in this problem, we have a basketball that hits the ground at speed v1 theta 1, and this is state 1. Then it rebounds with speed and angle, state 2, and then it reaches a peak height at state 3. So we're given mass, initial speed, initial angle, coefficient of restitution with the ground, and we need to find v2, theta 2, and h3. So we know that from 1 to 2, there's a collision here. Momentum is conserved. So that is momentum conservation between the basketball and the earth. The earth will shake a little bit. The basketball will move a significant amount. So we're just going to use the E equation, since really it's like there's only one object. So then we have E equals negative v2y. So let's say this is the y direction, this x direction. So this here is going to be our plane of contact. And this here is line of impact, because the force from the earth is in the vertical direction. No force in the horizontal. So we have negative of v2y minus 0 over v1y minus 0, because there's no second object. So we just got that. So then negative E v1y equals v2y. And now if we put numbers into there, negative 0.8 times v1y, which is v1 sine theta 1, but it's negative because it's going down. So that's going to be 0.8 times 4 sine of 50 degrees, which equals 2.45 meters per second equals v2y. And then in the x direction, let's see, so this is y, and now here in the x, we know that velocity is conserved. So v1x equals v2x equals v1 cosine theta 1. So then we have 4 cosine 50 degrees equals 2.57 meters per second. So then to find the total velocity, we just square these and take the square root. So v2 equals square root of 2.45 squared plus 2.57 squared equals 3.55 meters per second. And then the angle, theta 2 equals tan inverse of v2y over v2x, which we know since v2y is smaller than v2x, we know this angle's got to be less than 45 degrees. And theta 2 equals 43.6 degrees. So that gives us the velocity at state 2. Now from 2 to 3, we know that energy is conserved. There's no collision, so we say no, like momentum's not going to be conserved. We can forget about that. But we know that an object moving, going to a height, will have the energy conserved. So potential energy at 2 plus kinetic energy at 2 equals potential energy at 3 plus kinetic energy at 3. Well, originally, there's no potential energy. It has a kinetic for sure, because it's moving, but there's no potential at state 2. Now at state 3, it's up above the ground, so it definitely has a potential. And then it is still moving horizontally, so it has a kinetic. So then 1/2 mv2 squared equals mgh3 plus 1/2 mv3 squared. But we know that v3 equals only horizontal. So v1x also equals v2x, which equals what we found down here, that 2.57. Okay, so now we can cross out mass. We put in numbers, so we have 1/2 times 3.55 squared equals 9.81 H3 plus 1/2 times 2.57 squared. And this comes out to be 0.306 equals H3. So to solve this problem, we had the diagram and assigned coordinate frame, figured out line of impact, plane of contact. From 1 to 2, we recognized that there was a collision, so momentum was conserved. So we split up into x and y components, solved for velocities, and then from 2 to 3, we saw that energy is conserved. So we just plugged things in and solved out for final height.